Hey chemists, we're talking this time about molecular polarity, not the polarity of individual bonds, but of molecules overall. Remember that that bonds are polar when electrons are shared unequally because of unequal electronegativities. So remember that those involve partial charges. The one that's less electronegative is partially positive. Whoops. The one that is more electronegative is partially negative. Now, this matters when we look at the whole molecule, because if the molecule has partial charges on it, let's look what happens here. So here we've got nitrogen is partially negative on this molecule, and the hydrogen is partially positive. Same goes for all three bonds. Well, because of the shape of this molecule, it has a positive end. In this case, it's drawn so that the bottom is the positive end, and the top is the negative end. It's got that partially negative nitrogen. And so this whole thing is polar. We call it a dipole. Dipole is another word for polar molecule. And we draw this symbol for it, where the plus goes at the positive end of the molecule and the arrow goes toward the negative end. Let's take a look at water. It's the same thing. The oxygen is partially negative. Both hydrogens are partially positive for their bonds. Because water has this bent shape, we can arrange it so that there is a positive end to the molecule and a negative end to the molecule. Let me show you what I mean about that by looking at some where this is not the case. Here we've got some molecules that are symmetrical. They're symmetrical all the way around. So if we do that same thing here, we say, okay, carbon is partially positive, chlorine is negative for all four of these chlorines. Does this molecule have a positive and negative end? Nope, it does not. It only has negative ends. Well, that's not polar. Polar means two opposite sides. So in this case, even though it has polar bonds, it is a non-polar molecule because it's symmetrical. All that polarity cancels out. Same thing happens with carbon dioxide. Carbon's partially positive. Both oxygens are partially negative. Because it's a linear molecule and both ends are negative, it doesn't have a dipole. It doesn't have two opposite ends. And so this is another non-polar molecule. The other way that a molecule can be non-polar is if it has all non-polar bonds, because then there aren't even any partial charges to balance out. All right, so let's practice one. Here, we need to figure out if this molecule is polar or not. And so we do the math. We find oxygen is 3.5 and chlorine is 3.1. So the difference in electronegativities, 3.0 is 0.5. So this is a polar bond. We've got a polar bond here, and the partial negative goes with oxygen, partial positive with chlorine. All right, we draw the Lewis structure. Remember, oxygen has two lone pairs. Chlorine has three. And then we take a look at this. It's not symmetrical because it's got these two lone pairs are on one side and the two chlorines are on the other side. They are partially positive. Oxygen's partially negative. So here we have a polar molecule. Now let me just point out to you one error that people might make. They could draw it as ClOCl and put the lone pairs like this and then say, oh, it's a symmetrical molecule. You have to think about the three dimensions of this one. Remember, this is a tetrahedral electron geometry, and so it's going to be bent. These two chlorines are not 180 degrees apart from each other. So just be cautious of that. All right, there are some practice ones for you to do, and I would love to talk more about this with you chemists. Let me know when you need help with it.